3 halves, right? So if I'm here, that's the largest distance. That's the farthest away I can be from 2, okay? So the distance between x and 2 is at most 3 halves. Questions? Okay, so now I want to continue. I'll just write underneath this, or you write underneath this, okay? So that now is less than or equal to 6 times 2 to the 4th. Okay, now I substitute the absolute value of x minus 2. I substitute in 3 halves. That's raised to the 4th over 4 factorial.
What is that less than or equal to? What is that?
Hold on.
Raised to?
And here I replace.
Oh, I see. Okay.
This, I'm continuing from here, so this is less than or equal to what I just wrote over there. Okay? And so remember, you have to include the less than or equal to sign, okay? Because here, I just replaced absolute value x minus 2 by 3 halves, but they're not equal. We just found that the absolute value of x minus 2 is less than or equal to 3 halves, so this whole thing is less than or equal to whatever I plugged in here. I plugged this in 3 halves into here, so that's less than or equal to this, not equal to, because the absolute value of x minus 2 is not equal to 3 halves, it's less than or equal to. Questions so far? So now we just simplify. Okay, so this is equal to 6 times 2 to the 4th. 3 halves of the 4th can be rewritten as 3/4 over 2 to the 4th. And then I have times 4 factorial. And so here, the 2 to the 4th cancel, so this is why in step 2 I didn't want you to simplify, okay, and multiply out, because now we can just cancel out terms. It'll make computation much easier, okay? So now we cancel out the 2 to the 4th, and we're left with 6 times 3 to the 4th over 4 factorial. Or actually, I won't write 4 factorial. I will write 4 times 3 times 2 times 1. And so now 3 times 2 is 6, so the 6's cancel and left with 3/4 over, 3 to the 4th over 4. Okay, so the error, absolute value r sub 3 of x, is less than or equal to 3 to the 4th over 4, which is 81 over 4. And so now, lastly, I want to interpret what this means. And if you don't have room, you can write it at the top of the next page. It's just a sentence here. Okay, so anytime I ask you to interpret what your answer means, okay, you're going to say something along the lines of this. Okay, so for any k in the interval from 1/2 to 5/2, if we plugged k into the 3rd degree Taylor polynomial, we would be off from f of k equals ln k by, at most, 81 81/4 is 20.25. Okay? So basically, this right here is what I found in part A, right? And so we had, this was a third degree polynomial that was the function itself, so we're approximating the function ln x by this third degree Taylor polynomial. So if I plugged in any value between 1/2 and 5/2, if I plugged it into here and I plugged it into here, the difference between the two is at most 20.25. And that's a lot, right? If you get 60 on an exam, that's totally different than if you get 80.25 on an exam. It's a huge difference. That means this is a terrible approximation, right? It's not a good approximation.
Is that part of our interpretation?
Huh?
Good. Is that part of our interpretation?
If you decide whether it's a good or bad approximation?
Yeah.
And not so much as this part. This is more of what I want you to say. Hi.
I just need to know how many rows of
Oh.
columns of desks.
Okay.
Excuse me.
Questions? Aya, you awake over there?
So did the guy who do all this, was his name really Taylor?
Guess you'll find that out on the quiz on Friday.
I think we would want to know that before the quiz.
What?
I think we want to know that before the quiz.
Anyways. So, alright, so now we move on to our last example. Okay? And so here, I want to use a function f equals x cosine x. Okay, so I want to find the third degree Taylor polynomial. So we're ready to do 2 examples of these. Alright, so let's do the same thing here. Find the derivative. So if f equals x cosine x. And now I find f prime. Okay, so I do product rule. So I have cosine x minus x sine x. F double prime is negative sine x minus sine x. I just had a brain fart. Minus x cosine x. Okay, so that becomes negative 2 sine x minus x cosine x. And now f triple prime, I take the derivative of that, negative 2 cosine x minus cosine x plus x sine x. And that simplifies to negative 3 cosine x plus x sine x. Okay, so now we plug in 0, so I have f of 0, and here I have an x, so I just get 0. F prime of 0 is cosine 0 minus 0, which is 1, because cosine 0 is 1. F double prime of 0, okay, equals negative 2 sine 0 minus 0, which is 0, sine 0 is 0. And then f triple prime of 0 equals negative 3 cosine 0 plus 0, which is negative 3. Okay, in step 3 now I'm going to write out the original formula. T to the degree of x equals f of 0